This is mathheals.com if you want to come here for more links to YouTube math videos. And let's take a look at adding and subtracting rational expressions with unlike denominators. So let's take a look at our first problem. And we got 4x minus 8 over x squared minus 9x plus 14 plus x plus 3 over x minus 7. This one's actually got a little bit of a shortcut, which I'm going to ignore, so we can see something special at the end. And this is adding and subtracting rational expressions with different denominators. Step 1. Factor all your denominators. So factor all your denominators. So this first one here is the PSD method. So the top part is 4x minus 8, and the bottom part is x minus 2 times x minus 7. I won't show all the steps for factoring anymore. If you're not very comfortable with factoring, I'd recommend you go back and watch those videos where we go over these methods. Now, the shortcut on this one is if I factored a 4 out of the top, something nice would happen, cancel, and give us something decent on this problem. But I don't want to do that because I want to demonstrate something. I like steps to work all the time, and that's kind of a shortcut, and I typically tend to ignore shortcuts. Step 2. That sounds bad, doesn't it? Ignore shortcuts. But I think that's where students have trouble with in math, is you show them a bunch of shortcuts and they get lost. They don't know when to use them. Now we're going to figure out our LCD and rewrite each fraction. So rewrite each fraction with the LCD. Okay. If I look at my first factor in the denominator, the x minus 2, I'm looking for the greatest number of x minus 2's in any single denominator. There's 1 here, none here. So the greatest number of x minus 2's in any single denominator is 1. Then I go to my x minus 7. I'm looking for the greatest number of x minus 7's in any single denominator. There's 1 here, there's 1 here. So the greatest number of x minus 7's in any single denominator is 1. So that would be our LCD. So we're going to rewrite each fraction with that new denominator. Now our first fraction here already had that denominator, so we're fine there. We don't need to change that at all. Now our second one, we had an x minus 7. The x minus 7 is still there. The new thing downstairs in the denominator is the x minus 2. So whatever new item you put down here, you have to put up here. The mathematical rule on that is whatever you multiply by the top, you have to multiply by wherever you multiply by the bottom, you have to multiply by the top. Well, I got 4x minus 8 over x minus 2 times x minus 7. And I'll multiply these together. X times x is x squared. X times negative 2 is negative 2x. 3 times x is 3x. And 3 times negative 2 is negative 6. Over this. Which gives us 4x minus 8 over x minus 2, x minus 7, plus, combine together like terms in any step, negative 2x plus 3x gives us 1x, or just x, minus 6, over that denominator. Now step 3. Add or subtract the top parts. the numerators, and put into a single fraction. So add or subtract the top parts and put it into a single fraction. So we got 4x minus 8 plus x squared plus x minus 6 all over x minus 2, x minus 7. Grab a drink here. Well, combine together like terms at any step. The x squared remains. I'm putting it in standard form while I'm writing it down. Here we got a 4x plus x. That gives us 5x. And here we got negative 8 and negative 6, which gives us negative 14. Now step 4. Factor the top, factor the bottom. Unless you've actually multiplied it through, you shouldn't have to factor your denominator. It should already still be factored. But the top part here, this is the PSD method. And this factors as x plus 7 times x minus 2. And the denominator remains as is. And step 5, cancel if possible. Notice I have an x minus 2 here and x minus 2 here. Those are going to cancel. So our answer is x plus 7 over x minus 7. And let's look at our second problem. We're going to go through the same steps on every one of these. So here we got 9 over x minus 3 plus x plus 3 over x squared minus 9. Oh, and I meant to, on that last one, the way things worked out, canceled and so forth. If I had simplified that problem up front, then I wouldn't have been able to cancel at the end. So that's why I mentioned it shows something nice if we do that. Now this one here, let's take a look at it. See how this factors is x plus 3, x minus 3? I'm going to use that shortcut here and show it both ways. So again, we're factoring all of our denominators. So this is a difference two squares. This factors as x plus 3 times x minus 3. And this has an x plus 3, this has an x plus 3, so those are going to cancel. And we got 9 over x minus 3 plus 1 over x minus 3. Well, they got the same denominators already, so I don't have to get the LCD after I've canceled. So I just add together the top parts. 9 plus 1 is 10. X minus 3. Okay, that's if you see the shortcut on canceling. But let me show it the other way. Because the other way works all the time. And it actually will show something nice because we'll have to cancel. But again, we're going to factor all of our denominators. This is difference two squares. So I get 9 over x minus 3 plus x plus 3 over x plus 3, x minus 3. And that's step 1. Factor all of your denominators. Step 2, figure out your LCD and rewrite each fraction with that. I start with my first denominator, x minus 3. That's our factor there. So we're looking for the greatest number of x minus 3s in a single denominator. There's 1 here, 1 here. So the greatest number of x minus 3s in a single denominator is 1. Then I go to my second fraction here, and I have an x plus 3 downstairs. And I'm looking for the greatest number of x plus 3s in any single denominator. There's none here, 1 here. So greatest number of x plus 3s is 1. So this would be our least common denominator. Now this one already has that, so we're fine there. On our first fraction, We had an x minus 3. The x minus 3 is still there. The new thing downstairs in the denominator is the x plus 3. So whatever new item you put down here, you have to put up here. Whatever you multiply by the bottom, you have to multiply by the top. Well, 9 times x is 9x. 9 times 3 is 27. Like that. Okay, step 3. Add or subtract the top parts and put into a single fraction. So I got 9x plus 27 plus x plus 3 all over x minus 3 times x plus 3. Combine together like terms in any step. 9x plus x is 10x. 27 plus 3 is 30. And that remains as is. Step 4. Factor the top, factor the bottom. The top part is GCF. I can factor out of 10. And that gives us x plus 3. Step 5. Cancel if possible. Well, here's an x plus 3, here's an x plus 3. So those are going to cancel. And we got 10 over x minus 3 is our answer. Which happens to match what we got right here. But you can see the steps are a little bit more than that. But again, those 5 steps will work on all those problems. If you see that shortcut, fantastic. Go ahead and use it. Yeah, let's click on the next problem. This one's just a simple number example. So we got 1/12 minus 5/16. Well, here, and I put this in here to demonstrate this is the same thing we have been doing with numbers. Like 12 is 2 times 2 times 3. We're factoring the denominators. Minus 5 over 2 times 2 times, well, 4 2's. Like that. Step 2. Figure out your least common denominator and rewrite each fraction with that. I look at my first factor, 2. I'm looking for the greatest number of 2's in a single denominator. There's 2 of them here, there's 4 of them here. So the greatest number of 2's in a single denominator is 4 of them. I then go to my next factor, 3. I'm looking for the greatest number of 3's in a single denominator. There's 1 here, none here, so it'd be 3. So that would be our LCD. Okay. Now let's look what new thing was put down below. Here we had a 2, that 2's still there. Here we had a 2, that 2's still there. Here we had a 3, that 3's still there. The new item downstairs is a 2 and a 2. So I'm going to have that on top also. Now over my second fraction. I had a 2, that's still there. Second 2 still there. Third 2 still there. Fourth 2 still there. The new thing downstairs is a 3. So we have to multiply the top part by 3. So that gives us 4 over, this right here, minus 5 times 3 is 15 over this. Well, add or subtract top parts. 4 minus 15 is negative 11 over this. Now step 4 says factor your top, factor your bottom. 11's prime. I can't do anything with it. So actually, all we can do here is go ahead and multiply the bottom parts together. 2, 4, 8, 16 times 3 is 48. So our answer is negative 11/48. So again, we're not doing anything special. This is the exact same steps we did when we were working with numbers. Let's look at this problem. Got x minus 3 over x plus 5 minus x plus 3 over x minus 5. Step 1. Factor all of your denominators. Well, these can't be factored. Step 2. Figure out your LCD and rewrite each fraction with that new denominator. I start with my first factor, the x plus 5. I'm looking for the greatest number of x plus 5's in any single denominator. There's 1 here, none here, so the greatest number of x plus 5s is 1. The answer to that question is almost always 1, by the way, when you're dealing with these more complex problems. Now go to my next factor, the x minus 5. I'm looking for the greatest number of x minus 5s in any single denominator. There's none here, 1 here, so the greatest number of x minus 5s is 1. So that's our LCD. And we're going to rewrite each fraction with that new denominator. Now looking at our first fraction, it had an x plus 5, the x plus 5 is still there. The new item down below is the x minus 5. So we have to put it up on top also. So whatever is down here has to go up here. Looking at our second fraction, we had an x minus 5, that's still there. The new item down in the denominator is the x plus 5. So we have to put an x plus 5 up here. Well, multiply these together. X times x is x squared. X times negative 5 is negative 5x. Negative 3 times x is negative 3x. Negative 3 times negative 5 is 15 over our denominator. Over here, x times x is x squared. X times 5 is 5x. 3 times x is 3x. 3 times 5 is 15 over our denominator. Combine together some like terms. So we got x squared, negative 5x, negative 3x is negative 8x plus 15 over this. Minus x squared, 5x plus 3x gives us 8x plus 15 over that. Okay, step 3. Add or subtract the top parts and put it into a single fraction. Now remember, if you have a negative out in front of your fraction, that flips the sign of all the terms up on top. So we got x squared minus 8x plus 15 minus x squared minus 8x minus 15 over x plus 5, x minus 5. Again, that negative flips the sign of all of these. Well, combine together like terms at any step. X squared minus x squared, those cancel each other out. Negative 8x and negative 8x is negative 16x. 15 minus 15 drops away. So you got negative 16x over x plus 5, x minus 5. Now there's no factoring left to do and canceling. There's nothing that's going to cancel. So that's our answer. Let's look at our next problem. I'm going to start a new page here. Got x over x plus 2 minus negative 3 over x squared plus 4x plus 4. Step 1. Factor all of your denominators. X plus 2 can't do anything with. X squared plus 4x plus 4, that's the PSD method. So this factors as x over x plus 2 minus negative 3 over x plus 2 times x plus 2. Step 2, figure out what your least common denominator is and rewrite each fraction with that new denominator. Well, my first factor is x plus 2. I'm looking for the greatest number of x plus 2's in a single denominator. There's 1 here, there's 2 here. So the greatest number of x plus 2's in a single denominator is 2. And that's our only factor, so that's our LCD. Now this second fraction is good as is, but our first one isn't. We had an x plus 2 down here, we still have that x plus 2, but the new item down below is another x plus 2. So we have to put that up on top. Whatever you put down here, you have to put up here. Well, x times x is x squared. X times 2 is 2x over this. Now remember, well, let me do that in the next step. Step 3. We want to merge these into a single fraction, add or subtract the top parts. Remember, if you have a negative out in front, that's going to flip a sign of everything up on top. So we're going to get x squared plus 2x plus 3 over x plus 2, x plus 2. Step 4. Factor the top, factor the bottom. The top part is PSD, x squared x, no number in front of the x squared. And it factors as, what does it factor as? Let me double check something here real quick. Negative, okay, multiply that, x squared plus 2x plus 3. It doesn't factor, so this is our answer right here. That's interesting. Looks like it should factor. Huh. Let's look at this one. So we've got 3x plus 2 over 2x minus 12 minus x plus 4 over x minus 6. Our first step is to factor all of our denominators. This one is GCF, and the other one, x minus 6, I can't do anything with. So we've got 3x plus 2 over 2 times x minus 6 minus x plus 4 over x minus 6. Well, we need to figure out our LCD. So we'll go to our first factor, the 2. I'm looking for the greatest number of single 2's in a single denominator. Well, there's 1 2 here, there's no 2's here, so we have 1 2. Now I go to my next factor, the x minus 6, and I'm looking for the greatest number of x minus 6's in a single denominator. There's 1 here and 1 here, so the greatest number of x minus 6's in a single denominator is 1. And that'd be our LCD. Now the first fraction already has that, so we leave it alone. Our second one had an x minus 6 down here, the x minus 6 is still down there. The new item down below is a 2. So we have to multiply the top part by 2. So we got 3x plus 2 over 2 times x minus 6 minus 2 times x is 2x, 2 times 4 is 8 over this denominator. See, what was that, step 2? Yeah. Step 3, add or subtract the top parts and put it into a single fraction. Remember, a negative out in front of your fraction flips the sign of everything on top of the fraction that follows it. So we're going to have 3x plus 2 minus 2x minus 8 over 2 times x minus 6. Well, 3x minus 2x is x. 2 minus 8 is negative 6. Now step 4 we really don't have to do. Step 4 would be to factor the top, factor the bottom. And then step 5 is to cancel. So x minus 6 and x minus 6 cancels there, and we're left with 1/2. And that's our answer. And let's look at our last problem. We've got x minus 3 over x squared minus 4x minus 7x plus 1 over 4 minus x. Okay, now we want to factor the denominators. This one is GCF, and this one's wrong order. So we're going to have x minus 3, and here we'll factor an x out, and that gives us x minus 4. Now this one I'm going to rewrite as negative x plus 4. And once I do that, I see it has a GCF. Because remember, if your first term is negative, you always factor out a negative. So this now becomes negative 1 times x minus 4. When you factor out a negative 1, it flips the sign of everything. So the negative x becomes positive x, the 4 becomes a negative 4. So we got x minus 3 over x times x minus 4. Now this negative here, I could go ahead and put that out in front of my fraction. And then I'd have a negative negative, which becomes a positive. By doing that, it actually makes our problem a little bit simpler. Okay. Figure out what our LCD is. Well, I'll start with my first factor, the x. And it's a single x. That's different than x minus 4. So we're looking for the greatest number of single x's in a single denominator. There's one here, none here. So the greatest number of single x's is 1. Then I go to the x minus 4. I'm looking for the greatest number of x minus 4s in a single denominator. There's one here, so it'd be 1. So that'd be our LCD. Now our first fraction already has it, so we leave it alone. Now in our second fraction, we had an x minus 4. The x minus 4 is still there. The new item down in the denominator is an x, so we have to put an x up here. Whatever you multiply by the bottom, you have to multiply by the top. So that gives us x minus 3 over x times x minus 4. Plus, and I'll multiply the x through, x times 7x is 7x squared. X times 1 is x over x times x minus 4. Add or subtract your top parts and put it into a single fraction. So I got x minus 3 plus 7x squared plus x over x minus 4. Now I'm going to put it in standard form and combine together like terms. So I got 7x squared. X plus x is 2x minus 3 over this. And does this factor? 1 times 21, 3 times 7. That doesn't factor actually. So this would be our answer. Assuming I didn't screw up somewhere, which is always kind of a big if. Let me just double check myself real quick here. Okay, put that out in front. Okay, that's fine, that's fine. X minus 4, that's good. Okay, that's fine as is. Multiply top by x. 7x plus, yeah, that looks fine. Just doesn't look like it factors. Because 21, 1 times 21 and 3 times 7 are the only ones I can get. Nothing add or subtract to give you 2. So that's our answer. And the end of that section, I believe. So I'm going to go ahead and save it.